Today I'm going to show you how to predict future home prices in Santa Clara, California using historical prices in Santa Clara, California. I'm going to spend the first 3 to 5 minutes just walking through what's currently available on the market before proceeding to actually walking you through gathering historical data, loading the data set, applying models, interpreting the outputs, visualization so that we can see historical data, visualization so that we can see predictive prices, and ultimately decision making that could help us improve our profitability at the end of this. Let's get started. So as you can see, I'm in Santa Clara, California. This first home that comes up is a 3-bed, 1.5-bath, 1,200 square feet, zip code 95050. And again, it's crucial to always look at the areas and making sure you're looking at the most recent data so that you can predict off of future accurately. So this one, let's just take a look at this first one. It looks great. Seems like it's high ceilings. Nice and bright. Nice kitchen. Not bad. It was an hour ago. Open house this week. We like it. We like it. So if we go back, it's got outdoor space. Next one that we see is a 3-bed, 3-bath, 1,500 square feet for 1.69 million. Let's take a look at that. Looks nice. I like it. I like the outdoor space, a little 2 chairs out here, have a nice coffee. Love the living room. Extremely similar to the one we just saw. This is a 3-bed, 3-bath, 1,600 square feet, almost 2,000 square feet, 1995. Nice. We'll take a look at one more. I believe all these are single family homes. And just make sure. So second thing to note is we also want to classify our data points to be specific to the feature we're looking for. So giving our features price and homes, we want to make sure from a property type perspective we're linking back that lineage just for houses. For instance, we don't want to do condos, mobile, multifamily, etc. So filtering just for houses, we see that our results have reduced to 22 homes. Thankfully, the first 2 are still the ones that we looked at previously as homes. And now this one's a 2-bed, 1.5-bath for 1.495 million. Let's take a look at this last one. I like it. Nice and bright. Nice outdoor space. Kitchen. Love living room. Bedrooms. Nice. So I just took a look at the first 3 results that came up on Realtor.com. As we can see, this is what's currently available, and just taking a look at these data points, we have 2.1 million, 2.59 million, 1.69 million, etc. So now what I'm going to do is just proceed to actually loading the data set, historical data set, and applying the machine learning model so that we can accurately predict future prices. So I kind of gave it away. As you can see up here, ultimately we end up with cost savings of $242,000, and we'll get to that. First thing is just kind of addressing the problem statement, what I'm hoping to accomplish. So I'm looking at Santa Clara specifically. Do I want to invest now or later? So for instance, 1 month or 6 months, and I'll be applying and creating and building the linear regression models. So first thing, we just want to import our required libraries, pandas, numpy, matplotlib, plotlib, stats model, sklearn. So we just run this. Next thing that I want to do is actually load my data set. So this data is from 2023 to 2024, the previous 23 months. So n equals 23, and it starts, as we can see, January 1st, 2023, and my last data point is November 2024. So I'm just going to go ahead and load this. Now I want to view my data set, view my info, and as we can see, the 2 features, date and price, we have 23 values for each. I've loaded that in the cloud. So now I'm just going to take a look next at my first 4 rows and my last 4 rows just from a sanity check. So first 4 row, we can see starting January 1st, 2023, the price was 1.43 million. Last 4, or the 4th of the first 4, is May 1st, 2023, with the price of 1.37 million. Now I'm going to load the last 4, and we can see that the August 1st or July 1st was 1.62 million. August 1st was also 1.26 million. Last value is November 2024 at 1.67 million. I'm just going to describe the data. So average price over the last 22 months is 1.5 million. It's an important value for us to remember. Highest was 1.67 million, and the lowest was 1.37 million. Lowest, highest, average. So now we just want to take a look at the complete 22 months of data, and specifically the historical prices. Now these are very, very crucial because we're going to be applying our algorithms, linear regression models, on these historical data set. So we've loaded the last 22 months, last 2.5 plus years of the most recent Santa Clara single family home prices. Now I'm going to compute what those averages, highs and lows are. I've already done this, and again, it's always good to just double, triple check. So as communicated earlier, the average is 1.5 million, the highest is 1.67 million, and then the lowest is 1.37 million. Now what I'm going to do is just plot the historical data points. So as we can see, there's a positive correlation. It started off negatively as the months went by, so starting with 1.37 million, and then the prices decreased. And most recently, for instance, starting in July, we've seen a positive increase. And this pattern and trend has been one that we can observe since what, April, May of 2023. We can clearly see the prices have been going up in Santa Clara, California for single family, all the way through October 2023, and then it takes a dip starting in the new year of 2024, but then we can see that pattern and trend increasing in March. So very, very interesting visualization. So now we're actually going to continue to applying our algorithms. So specifically, I'm going to import my libraries from linear regression and absolute square error, mean square error. Similarly, I'm going to do the same for my linear regression. This line here, I'm going to validate the accuracy on the test data. So I'm splitting that to 80-20, as you can see here. Training, predictions, and then accuracy metrics. So we run this. Now we're going to be interpreting our slope, our intercept, absolute mean error, and root mean squared error on a test value. And we're going to do this later as well to ensure that our OLS results are something that we feel confident in. So again, kind of applying the previous logic above, we're going to do the historical data, but now we're going to put our trend line on there, our linear regression model, just to see what that looks like. So again, I'm just going to import linear regression, import numpy. I'm going to fit this XY model, and I want my color to be black, price, purple, and this should be Santa Clara single family home historical 2023 prices with the linear regression fitted on top, date, price in millions. So looking at the visualization, on the x-axis we have the dates, and then on the y we have the prices. The dates are indicated in black, these black dots. So for example, January 1st, 1.37 million, and then most recently November of 2024, a little over 1.65 million. And then the linear regression line is this in purple here. So now, getting towards the conclusion of this machine learning prediction project, and what I'll be doing is applying the OLS linear regression algorithms to determine with confidence what this looks like. So taking a look at our OLS results, we can see that our R squared is 0.909, our dependent variable is price, and our adjusted R squared is 0.904. So we can say with confidence that this is a pretty good model that I created based off our results. So we know that there is a relationship between price and date given the model's outputs. Similarly, the linear regression equation is here, so we can always apply future prices. So for example, here are the future predicted prices over the next 12 months, and we can see, for instance, December, which is the next month preceding November, the future predicted price is 1.67 million. In January, the future predicted price is 1.69 million, etc. So to conclude this Santa Clara predictions of single-family homes using machine learning models, what I'm going to demonstrate next are what I just went over, which is these future predicted prices, but now I'm going to visualize it using these models. So the first example that you'll see will be for 1/1/2025. So this month, we're going to predict what the future price will be for Santa Clara, California for a single family home. And let's take a look at that value. So I'm predicting the future price based off historical prices to be 1.67 million for a single family home in Santa Clara, California. The next two, I believe, are for March and June. So yes, predicted date, March 1st, 2025. So let's go ahead and take a look at that. So the future predicted price for a single family home in Santa Clara is going to be $1.7 million in March of 2025. And I believe the last one is for June 1st. Yes, so June 1st, 2025. Let's just take a look at the predicted price to see what that looks like. So 6 months from now, using historical data that we have available over the last 2.5+ years, the last 22 months, we're predicting the future price for a single family home Santa Clara to be $1.74 million. To summarize, what I just demonstrated are the future predicted price using machine learning models for Santa Clara, California. Now we need to arrive at a recommendation or a decision for users, investors, buyers, sellers alike. And to arrive at that recommendation, I'm going to take a look at the historical values and make a data-driven recommendation. So the average price over the last 22 months in Santa Clara, California for single family is 1.5 million. As we can see, the highest price being 1.67 million and the lowest price being 1.37 million. Given what we're able to see using the historical prices the last 22 months, 2.5+ years, I created a solution for predicting the projected percentage saved if you were to make a purchasing investment today. So if we take a look, for instance, the purchase price of the average last 22 months versus the predicted price, which we have, for instance, of March and June. I believe this 1.74 value is from the most recent, which is June, correct? So then we just compute what the projected percentage saved on the investment would be if we were to make an investment decision today. So we would have a projected percentage saved of 16.15%. So if I were to make a decision, I would ideally want to make a purchase like today, sooner, knowing that prices are getting higher and higher. Similarly, if I wanted to see the projected dollar saved on my investment, I would just put in the same values. So the purchase price and then the predicted price, and then I able to compute the projected saved. So doing that, we can see that the projected dollars saved on an investment would be $242, $874. So $242,874. Over 242K saved, making a purchase this month sooner as opposed to waiting until June 2025 when the prices are predicted to be 1.74 million. So in conclusion, I would go ahead and make a purchase sooner rather than later, given that, as we can see, the machine learning models were predicting January 1st to be the lowest. As we can see, prices are just going to keep getting higher and higher. And then similarly, from a cost savings perspective, 16.15 projected percentage saved on an investment with $242,874 projected dollars saved on the investment. So just, to summarize and to put that in perspective, these same homes, for instance, that are like 1.5 million now, 6 months from now, it's predicted to actually increase to 1.7 million, right? So these are great buys. Obviously you have to make that decision yourself, and just looking at the data and predicting future with confidence, the prices are projected to get higher. So with that, if you've learned something and enjoyed this video, please drop a like and subscribe. I'm Olu, and that was machine learning home price predictions for Santa Clara, California. OMS works. Till next time, take care.